If you recall, real zeros of a polynomial are where the graph crosses the x-axis. Factors of polynomials are when you take the real zeros. If x equals a positive number, then the factor is in parentheses x minus that number. And if the real zero is a negative number, then the factor is in parentheses x plus a. So you just flip the sign. So in example 1, we're going to look at this model of endangered birds, and that function right there is the graph that we see to the right. Our job is to figure out when the bird will become extinct if that model's accurate. The birds will be extinct when there are 0 birds, and since the number of birds is on the y-axis and time is on the x-axis, since 1990, so at 0 time, it's not at the beginning of time, it's in the year 1990, all we have to do is look at the line to see when all the birds will be gone, which would be when there are 0 birds, so when that line ends right there. If we look at the number that's on, it's between the 21 and the 27, and we can see the graph is going in increments of 3. So that would be 24 years after 1990. So if we do a simple addition problem, we will come out with the year 2014. So basically now all the birds are extinct, which is awful. Hopefully they did something to fix that. To finish this question, we're going to factor p of x, which means since we know that x equals 24, we can use synthetic substitution to figure out what the leftovers are when we divide that polynomial by x minus 24. So whether or not we start with the factor or we start with what the actual real zero is, we'll put positive 24 in the box for synthetic, and then we'll take all the coefficients. Negative 1 is first, and then 32, and then minus 224, and then plus 768. And we would go through the synthetic process. We would drop down the negative 1, and we would get negative 24. We will subtract those, and that's 8. 24 times 8 is 192. Then we get negative 32. And then we'll multiply negative 24 by 32. And we get negative 768, which means the remainder is 0. And our final answer is negative x to the second, so 1 degree lower. Instead of x to the third, we'll start with x to the second, plus 8x minus 32. One rule that I haven't really talked about yet is that we shouldn't have negative 1 as a leading coefficient. So we'll divide all of these numbers by negative 1, and we'll get our final answer, positive x squared minus 8x plus 32 is what's left when you divide out the x minus 24. So those would be the two factors, this one and that one. In this next example, all we have to do is figure out where the zeros are. So where does the red line cross the x-axis? We only care about the x-axis. We don't care about where it crosses the y-axis. All we want to know are what that point, and that point are. So, looking at the scale, it's going by 2's. So this is negative 2, 4, 6, 8. So if that dot's between negative 4 and negative 6, the first x is negative 5. The next one is right on negative 2. And the third one over there is halfway between the 6 and the 8, so it's 7. To write the factors, we put the x inside parentheses and we take the opposite sign. So instead of minus 5, it flips to plus 5. This negative 2 will flip to plus 2, and that positive 7 will flip to negative 7. How could you use synthetic substitution to show our answers are correct? If we were to divide each of those by the original function up here, we would get a remainder of 0, so they would divide evenly. Divide evenly into v of x. That's it.